Good day, viewers. You're welcome to my channel once again. I am Adeyeye Adeolu Peter. So today we want to look at phase, phase angle, and phase difference. And now we have a diagram on the board. There are questions below. Now, before I answer the question, you will have to define what phase is. What is a phase? What is a phase? Now, on a wave graph, 2 points are said to be in phase if they are at the same vertical distance from the origin and also traveling in the same direction if they are at the same vertical distance from the origin and are also in the same direction. So those points are said to be in phase. Now, for example, let's look at the diagram we have here. If you look at this diagram, which points do you think are in phase with point P? Which point? You can guess before I give you my own answer. You can look at it yourself and then tell me your answer according to the definition I just give. All right? So this point P. Which points are in phase with point P? So point P is in phase with point. Now, point P is at the origin. So you will ask yourself, which other points do you have at the origin? So that's what? Point R, on the horizontal. Point U, point W, and point A. But are they all in phase with P? No. If you look at P, so we have to check the directions in which they are traveling, although both of them are the same vertical distance. P is traveling downward according to the arrow here, but R is traveling upward. U is traveling downward. So U is in phase with P. So I write U. W is traveling upward. So W is out of phase. R is out of phase. Then A is traveling downward. So we also have A, meaning P, U, and A are in phase. All of them are on the horizontal line at the origin. And then they are also traveling downward in the same direction. So don't be tempted to say R is in phase with P. Don't be tempted to say W is in phase with P. So R and W are totally out of phase with P. All right? Now let's answer the questions we have below. The question says the waveform of a particle is represented in the diagram below. What are the phase angles of the particles at points P, Q, and W? So what are the phase angles? Now, if you can remember the general equation of motion of progressive wave, the general equation of progressive wave, which says y equals a sine 2 pi ft minus 2 pi x over lambda. Now, remember this particular expression here is phase angle, which is phi. So phi, I will write it our phase angle, which is phi. Phase angle phi will be equal to 2 pi x over lambda. All right? Now, what does x stand for? X is the horizontal distance of a point on the wave, on the graph, from the origin. It can be measured in meter, it can be measured in centimeter. While lambda, if you are familiar with wave, lambda is the wavelength. The wavelength, that's the distance between two successive crests or two successive troughs. Wavelength can also be defined as the distance between 2 points that are in phase. For example, wavelength is the distance between P and U, or U and A. The distance between two successive points that are in what? That are in phase. All right. So please take note of this phase angle phi. Phi is a Greek word, Greek letter phi. All right. So take note of that. 2 pi x over lambda. So this is our phase angle. So what are the phase angles of the particle at point P, Q, and W? Now at point P, remember we got one now at P. So what do you think the phase angle is at point P? At P, what is so now we have to find x first. What is x? Which is the horizontal distance, horizontal displacement from the origin. Now P is at the origin. Since P is at the origin, what is x? X will be equal to what? 0. Since P is at the origin. So we don't have distance, horizontal distance from the origin. Now what will happen to phi? Phi will now be equal to 2 pi times what? 0. You substitute 0 for x over lambda. Now the whole of this goes to 0. 2 pi times 0 gives us 0 over lambda, which is equal to 0. So it means the phase angle at point P is equal to 0. All right? What of at point Q? Now, at point Q, we have to count how many wavelengths we have from the origin, which is from point P. All right? Now, from here to here, from P to U is one wavelength. Now, please, for your information, if I divide here, if I divide PR, this is lambda over 4. Lambda over 4. Are you following? So from here to here is lambda over 2. From P to R is lambda over 2. While from P to U is what? Lambda. That's the distance between two successive points which are in phase. So how many waves do you have? How many wavelengths do we have from point P to Q, from the origin to Q? Because the origin is point P. So here to here, P to U is one wavelength. Then U to A is another wavelength. So from P to Q. Sorry, I think I made a mistake here. From P to Q, this point Q, right? So from P to Q is how many wavelengths? That's going to be lambda over 4. Lambda is our wavelength. So it means our length, our distance x, which is from here to here, distance x from here to here, if you trace here to point Q, our distance x is equal to lambda over 4. Now we are going to substitute that here. So phi, which is the phase angle, will now be 2 pi times lambda over 4, all divided by lambda. Now lambda can cancel lambda, so that we now have 2 pi over 4. Now what is 2 pi? Our pi is in radian, and 2 pi radian is 360 degrees. Therefore, phase angle will be equal to 360 over 4. And what is 360 over 4? We are going to have 90 degrees. So that's the phase angle. All right? 90 degrees is the phase angle for point Q. Now let's go to point W. Point W is here. So how many wavelengths do we have? From here to here is one wavelength. Then from P to U is one wavelength. So we are going to W, from the origin to U, one wavelength. Then from U to W is lambda over 2. Yes, lambda over 2, half wavelength. That's lambda, 1 lambda plus lambda over 2. Or you just say lambda over 4 plus lambda over 4. Here is also another lambda over 4, lambda over 4. Yes, lambda over 4, lambda over 4. So how many? So cut each of these into half. So 1, 2, 3, 4, 5, 6. That is what? That is 6 lambda over 4. And if you reduce it, 2 here is 2, 2 here is 3. That's 3 lambda over 4. So it means x, our distance from the origin, by the time we get to point W, x is equal to 3 lambda over 4. Now, what's the phase angle at W? You use the same formula, phi equals 2 pi x over lambda, which is equal to 2 pi times, what is x? 3 lambda over 4 all over lambda. Lambda again takes care of this lambda, and then phi is equal to 2 pi times 3 over 4. 2 here, 1, 2 here, that's 2. That's pi times 3, 3 pi over 2. All right? But what is pi? Pi radian, don't forget that pi radian, since 2 pi radian is 360, pi radian is equal to 180 degrees. So we are going to substitute here. This is going to be equal to 3 times, this is going to be equal to 3 times, what is pi? 180 over 2, all right? 2 here, 1, 2 here, 90. And 90 times 3, or 3 times 90, that's 270 degrees. So it means the phase angle of the point W is 270 degrees. Now the next question says, what are the phase difference between points P and Q, and then point V and Y? So the phase difference between P and Q, and then V and Y, the phase difference. Now, what did we say our phase is? What is our phase? Our phase angle at point P. Roman figure 2 now. Our phase angle phi at point P is 90 degrees. Then that's at P. Then what is our phase angle? So we have to find our phase angle at each point. At point Q, what's our phase angle at? Sorry, that's 0 degree, not 90. Then at point Q, what's our phase angle? You know, point P is the origin, don't forget please. Then at Q, what's our phase angle? At Q, our phase angle is equal to 90 degrees. So at what? At Q. So phase angle phi at Q is 90 degrees. Now, so what's going to be the phase difference? Phase difference between Q and P will now be equal to the phase angle at Q minus the phase angle at P, which is equal to 90 degrees. So that's the phase difference. Now, what of V and Y? V and Y. Now, point V, we have to find the phase angle at V again. We have to find the phase angle at V and then at Y. So phi, which is the phase angle at V, is 2 pi x over lambda. Now, phi will be equal to 2 pi times, what is x at V? This lambda over 4, lambda over 4, lambda over 4, lambda over 4, lambda over 4. How many of these? 1, 2, 3, 4, 5. That's 5 lambda over 4 all over lambda. Okay, lambda takes care of lambda, 2 takes care of 4, that's 2 here. So we have 5 pi over 2. Okay, what is pi again? Pi radian, that's pi in radian is 180 degrees over 2. So 2 here, 1, 2 here, 90. And then 90 times 5, that's 450 degrees. So that is the phase angle at point V. Now, what of W? So phi at V equals 450 degrees. So we keep that one. Then what is phi at point Y? Phi at point Y, which is the phase angle at point Y, we see it's the same formula, 2 pi x over lambda, which is equal to 2 pi times. Now, what is our horizontal distance from the origin at point Y? So let me draw this again. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7. So by the time we get to point Y, we have 7. So x is equal to 7. Okay, so this is going to be 2 pi times 7 lambda over what? Over 4 over lambda. This is what I mean. This lambda over 4, 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 and lambda over 4. 1, 2, 3, 4, 5, 6, 7. That's 7 lambda over 4. Then this cancels this cancels this 2, this 7 pi over 2. If you calculate that, 7 times pi is what? 180, then over 2. 2 here 1, 2 here 90. So 90 times 7, that is going to give, okay, that's 630. That's 630 degree. All right. Now, it means our phi, our phase angle at y is equal to 630 degrees. So what's the phase difference? Phase difference. But before we calculate phase difference between V and Y, now this 630 is already more than a complete cycle. All right. What's a complete cycle? That is 360 degrees. So we are now going to do 630 minus 360. Anytime you have a phase angle more than 360, you subtract. So what do we have? 630, 360. Okay. This 0. Okay. This 7. And then this 2. So that's 270 degrees. All right. So we can now find the phase difference between V and Y. So the phase difference between V and Y will now be equal to 270. Sorry, I made a mistake here again. For this one is going to be 450 minus what? 360. And that's 450, 360, that's 0, 3 here. Okay, that's 90. So we have 90 degrees. So the phase angle at V is 90 degrees. So anytime you have a number more than 360, which is complete oscillation, all right? So this is going to be 270 now minus 90, because definitely the phase angle at Y should be more than that at what? At V. So 270 minus 90 will give me 180 degrees. So that's the phase difference between V and Y. Now, which of the points will be 270 degrees out of phase with point Q? 270 degrees out of phase with point Q. Now, it means the phase angle difference between that point, between those points and point Q must be what? 270. Meaning phi now, number 3, phi is equal to 270 degrees. But what is phi? Phi is 2 pi x over lambda. Now we are going to find the horizontal distance of those points from point Q. So we substitute the value of phi, which is 270, equals 2 pi. 2 pi is what? That's 360 degree times x, then over lambda. All right, can we see? Okay, so if we make x the subject of formula, so 275 equals 360x. All right, so x will be 227 over 36. Okay, 3 here, or 9 here, that's 3, 9 here, that's 4, and s is 3 pi over 4. So this is the horizontal distance between those points and point Q. But we have a general formula which we have to use. So if you want to get those points, this is the formula you're going to use. So that x will be equal to 3 over 4 plus n into lambda. This formula is very important, where n are whole numbers, where n equals 0, 1, 2, 3, and so on and so forth. Now, if you are to use this formula, now I got this formula from here. So depending on what you get as your x, so our x is 3 over 4. So depending on what you get, that's what we inform what you are going to write in this formula. So what do we have? From point Q. Point that be 270 out of phase with point Q. All right? So how do we get that? Now, we are not going to start from 0. Substitute the values of n here. N equals 0, n equals 1, and so on and so forth. So for n equals 0, this is going to be 3. That's going to be 3 over 4 plus 0 times lambda, which is equal to 3 over 4 times lambda, which is 3 lambda over 4. That's the first point. Now the second point, this is first point. Now the second point, x will be equal to 3 over 4 plus 1 into lambda, which is going to give me, if I simplify, this Sm is 4, 3 plus 4 lambda, which is 7 lambda over 4. So this point, if I pick another point, if I pick n equals 2, we are going to have a point, a distance more than what we have on this graph. All right? So these are the 2 points we are looking for. 3 lambda over 4, the point that is 3 lambda over 4 from point Q, and another point that is 7 lambda over 4 from point Q. So let's go. So from point Q, this lambda over 4, this is 1 lambda over 4, lambda over 4, lambda over 4. How many of them do we have? 1, 2, 3. So where do we have 3 lambda over 4? Point what? Point U. So it means the first point that is 270 degrees out of phase with point Q is, number 1, we have point what? Point U. Then the other point is 7 lambda over 4. This 1 now, 2, 3, 4, 5, 6, 7. That's point A. Any other point you pick, we go beyond here. For example, let's try 3 again over 4 plus, if n is equal to 2, then times lambda, we are going to have 3 plus 8 over 4 times lambda, which is equal to 11 over 4 lambda. So we can't have 11 over 4 lambda. 11 times lambda by 4, we can't have it here. All right, so that is it. So please like, comment, share, subscribe. Thank you.